Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. This is the first video, guys, where I'm tackling a question on rates of reaction. Please do expect a total number of 11 questions, and each and every question will have its own video. And please note that, guys, all of these questions are extracted from past exam question papers. It's very important for you to know how to tackle such questions because it will give you an edge whenever you write your exam. So please, guys, do share the video to your peers so that they may have the same edge as you. Okay, we are being asked to consider the following decomposition reaction that takes place in a sealed 2 cubic decimeter container. So we are given the volume of the container. The volume of the container is just 2 decimeter cubed. In this container, guys, nitrogen pentoxide will literally decompose into nitrogen dioxide and oxygen. Are you together? Nitrogen pentoxide will decompose into nitrogen dioxide as well as oxygen. Okay, and then we are told that the graph below shows how the concentration of nitrogen pentoxide and nitrogen dioxide change with time. Okay, we have two curves over here, curve A and curve B. So curve A will literally represent the products. Why? Because at the beginning of the reaction, the products were not formed yet, and hence the concentration of my nitrogen dioxide will simply be 0 moles per cubic decimeter. Are you together? So this simply means that curve B will represent my my reactants. In this case, I only have one reactant which will decompose into nitrogen dioxide and oxygen, and the name of my reactant is basically nitrogen pentoxide gas. Okay, so curve A will represent the product, which is nitrogen dioxide. Curve B will simply represent the reactant, which is nitrogen pentoxide. First question, they want us to refer to the graph above and give a reason why curve A represents the change in concentration of nitrogen dioxide. Because at the beginning of the reaction, the concentration of this curve was basically 0 moles per cubic decimeter. The only compound which was 0 moles per cubic decimeter at the beginning of the reaction is only nitrogen dioxide. Are you together? Okay. Then now we must consider the statement below. It says the rate of decomposition of nitrogen pentoxide is half the rate of formation of nitrogen dioxide. Is the statement true or false? Okay, let's check the stoichiometric coefficients. There's 2 and 4. It simply means we need 2 moles of nitrogen pentoxide to form 4 moles of nitrogen dioxide, which is basically true because if you check the ratios is basically 2:4, which can be rewritten as 1:2. Are we together? So this basically means that for me to form 8 moles of nitrogen, I need to decompose 4 moles of nitrogen pentoxide. So yes, the statement is true that the formation of that the rate of decomposition of nitrogen pentoxide is actually half the rate of formation of nitrogen dioxide. The statement is true. I only need half of this to form whatever amount I need on the products. Are you together? Why? Because the ratio is simply 1:2. Okay. Now we are being asked to calculate the mass of nitrogen dioxide present in the container at 400 seconds. The mass of nitrogen dioxide present in the container at 400 seconds. Okay, 400 seconds is over there. And then the actual concentration, that's 200 times 10 to the power negative 4 moles per cubic decimeter. What do they want us to calculate? Or the mass of nitrogen. I can simply use the equation that says concentration is basically equals to the mass all over the molar mass multiplied by volume. I know the concentration, that's 200. The concentration is 200 times 10 to the power negative 4 moles per cubic decimeter. I'm looking for the mass, and then my molar mass for nitrogen dioxide. For nitrogen dioxide, it's basically a nitrogen, I believe it has a molar mass of 14. Please go there, guys, at the back of your question paper. There's a periodic table over there. You'll simply have nitrogen. The number which is written over there, just below, it's called the relative atomic mass number, and it's 14. Are you together? And then for oxygen is 16. But since I have 2 of the oxygens, I'll simply say this is 2 times 16. So the molar mass of nitrogen dioxide is basically 14 plus 16 times 2. This will give me 46 grams per mole. This is the molar mass. Are you together? So now all I have to do is to just substitute for me to calculate the mass of nitrogen dioxide at 400 seconds. That's 46 grams per moles. The volume, I was given the volume, it was 2 cubic decimeters. So the mass is basically 200 times 10 to the power negative 4 multiplied by 46, also multiplied by 2. So this will give me, excuse me about that, guys. And guys, excuse me, I'm really sick. I have flu, but I have to do this for you. That's 10 to the power negative 4 multiplied by 46 and 2. So I'll simply get an answer of 1.84 grams. So the mass of nitrogen dioxide at 400 degrees, the mass of nitrogen dioxide at 400 degrees is 1.84 grams. Okay, now they want us to calculate the average rate of production of oxygen at 700 degrees. The average rate of production of oxygen at 700 degrees. Okay, excuse me. At 700 degrees, the concentration available for A, let's check over there. Since we have 10 numbers between these numbers, 300 and 250, for us to know what each line represents, you simply have to say 300. It's 300 minus 250 all over 10. So each line will represent to 5. So this will be 255, 260. Excuse me. 265, 270, 275, 280. Where are we over there? 280. Let's check. Okay, so the concentration available of compound A is basically 280. Are you together? So, but remember that, guys, since you have stoichiometric coefficients, I know that for me to form 4 moles of nitrogen dioxide, that means I would have formed only 1 mole of oxygen. Are you together? And then since I have 2, it's, what's the value? Or the value is 280. Since I have 280 times 10 to the power negative 4 as my concentration, I want to know how much concentration have I formed for oxygen. So all I have to do is to just cross multiply. I'll simply have 280 multiplied by 10 to the power negative 4 is equals to 4x. If I divide both sides by 4, 280 divided by 4, this will basically give me x multiplied by 10 to the power negative 4. This will basically give me an answer of 7 times 10 to the power of negative 3 moles per cubic decimeter. But remember that, guys, X only represents the concentration of oxygen which is formed after 700 seconds. So therefore, for me to calculate the rate of formation of oxygen, or rather the rate of production, I'll simply say the rate is basically the change in the concentration of oxygen divided by the change in time. So I can simply say that 7 times 10 to the power negative 3, initially oxygen was 0 because at the initial stages I haven't yet formed products. So oxygen as well as nitrogen dioxide are both 0 moles per cubic decimeter. So divided by 700 minus 0. So I simply have 7 times 10 to the power of negative 3 minus 0 all over 700 minus 0. This will basically give me 1 times 10 to the power 2, 3, 4, 5 to the power of negative 5 in mole per cubic decimeter per second. So this is the actual rate of production of oxygen, guys. Né? The first thing we needed to do was to find how much nitrogen dioxide has formed. And since we know that for us to form 4 moles, or for us to form 4 moles of nitrogen dioxide, we only need a single mole of oxygen. Are you together? And then since we know the concentration of nitrogen dioxide, I want to know how much concentration of oxygen would I have formed. And then I obviously used my ratio and proportion to get the concentration of oxygen, and then I went to calculate the rate of reaction. So that was my rate of reaction over there. That's 1 times 10 to the power of negative 5 moles per cubic decimeter per second. Okay, and then now we are told that the Maxwell-Boltzmann distribution curve for nitrogen pentoxide initially present in the container is shown below. The initial concentration is now increased. Okay, what happens, guys, whenever we increase the concentration? Obviously, the rate of a chemical reaction will also increase. Are you together? Why is it increasing? Because by increasing concentration, that simply means there are more number of particles. There are more number of particles that will be present in the container, and hence our graph will spike a bit. Increasing concentration, guys, does not change the average kinetic energy. Are you together? It just helps us to have more particles colliding, and obviously, if more particles are colliding, we'll end up having more effective collisions, and hence the rate of reaction will be higher. Are you together? Okay. Firstly, they want us to redraw the distribution curve above in the answer book and label it as curve P, and then on the same set of axes, sketch the curve that will be obtained for the higher concentration, and label it Q. Né? This over here will be labeled Q. Are you together? It will have a higher peak. Why? Because the number of particles has increased. Are you together? Remember that, guys, by increasing concentration, we are increasing the number of moles because they are directly proportional. When I'm increasing the number of moles, I'm basically increasing the number of particles. Are you together? So whenever I increase the number of particles, my graph will just spike over there. It will have a higher peak. Molecules will still have the same average kinetic energy, and this over there will be the activation energy. So we can see that now we have more particles that has a greater activation energy as compared to curve P, because on curve P we only had particles over there. Man. On curve P, those particles were over there only. Are you together? Okay, so the curve would just be like this. So they didn't ask us to indicate activation energy as well as the average kinetic energy. So you just need to draw this. You just need to draw this, and then you'll be okay. And then now we are being asked, will the rate of decomposition of nitrogen pentoxide at a higher concentration be higher than, lower than, or equal to the original rate of decomposition? It will obviously be higher. It will obviously be higher. Why? Because whenever you increase concentration, you will have more particles in the container, and since there will be more particles in the container, we will end up having more effective collisions, and that's why we'll simply have a higher rate of reaction. That's the end of the video, guys. I really hope that the video helped you out. Just stay tuned, guys, and wait for more videos. Thank you.